Hi everybody. So here we are, our last section that we're going to go over for integer review. What happens when you have variables on both sides? We're going to look at whole numbers, but of course I'm going to also show you with fractions and we'll review that again. Number one, most important thing, you have to clean up the equation before you can begin to solve it. Both sides have to be clean. That means you have to do your like terms, your distributive property. You have to combine things so that you get down to just one variable on each side, one constant on each side. Then you can begin to move the variables all to one side. So you do need to move all the variables to one side, and you do that by using inverse operations. You must then isolate the variable and solve for it. So here's our first example. 7k equals 4k plus 15. You can see that I have a 7k and a 4k on both sides. So I can't have k's on both sides. I need to move it. I've decided to move the 4k to the left. This is a positive 4k, so I subtract 4k from both sides. Notice here are your directions on the right. I am left with 7k minus 4k. 3k equals my constant 15. Now both sides are cleaned up. K, I have variables only on one side, and I can do a simple one-step or two-step to solve. I need to have K isolated, so I need to divide both sides by 3, which is really every term by 3. K equals 5. You need to go slow when you do these because it's very easy to make a simple mistake. Another example. This time I have a distributive property to look at. I have 2 times parentheses y plus 6 equals 3y. You can see this is not cleaned up. Distributive property needs to be cleaned. 2 times y, 2 times positive 6, 2y plus 12. Now you see I have variables on both sides. Well, if I move the 3y over to the left, I'm left with 0 here. And you can do that. But in this case, I'm going to just subtract 2y from both sides. And I'm going to eliminate the 2y on the left. 12 equals 1y. That 1 becomes invisible. 12 equals y. Be aware that with math, we've talked about numerous times, there's many ways to solve an equation, depending on which operation you want to do first. The end result, we all get the same answer. So as long as you show your work and you can see your steps, we all get the same answer. Now, this was one of my favorites. You all saw this before in class. Do not panic, but this is fun. You look at one side at a time. So I have 3 minus 5b plus 2b. I have 2 like terms. A negative 5b and a positive 2 makes a negative 3b. Bring down my constant. My left side is done. Over here, I have a negative 2 minus 2 times 1 minus b. All right. I need to get rid of these parentheses. That means distributive property. Negative 2 times 1 is negative 2. Negative 2 times negative 1b, because that b has an invisible 1 in front of it. Negative 2 times a negative 1 makes a positive 2b. I'm not cleaned up yet. I still have 2 constants. They need to be combined. A negative 2 and a negative 2 makes a negative 4 plus 2b. Now both sides are clean. When both sides are clean, you can begin to move the variables. I've chosen to add 3b to both sides. Again, you could have added 4 to both sides, move the 4 over. You could move the 3, you could move the 2b. You get to decide, but you have to do one step at a time so that you can follow what you decided. I chose to move the b's to the right. Add 3b to both sides. These will cancel out. I am left with 3. I have a 2b and a 3b, I have 5b. My negative 4 comes down. Now I need to move that negative 4 to the left because now b is on this side, on the right, and it needs to live alone. Add 4 to both sides. 7 equals 5b. b still needs to live alone. Divide all terms by 5 because that's the inverse operation. 7/5 equals b, or 1.4 because that's the decimal version of b, of 7/5, or 1 2/5. Obviously, 1 2/5 is cleaner and more precise than 7/5 because that's an improper fraction. So you would want to go with 1 2/5 equals b, or 1.4. This looks complicated, but it really was not. Go back. Try to have fun with it. It really is fun once you learn how to do it. Let's take a look at another. Here I just have the distributive property. Look at it for a moment. You can see that I have to take the negative 2 times x, negative 2x. Negative 2 times a positive 3, negative 6. The right-hand side does not need to be cleaned. I'm ready to move my variables. You notice that I tend to, if I have a negative variable, a negative coefficient, I tend to move that one because I can make it positive, and we all like positive numbers better. So I add 2x to both sides. I'm left with just negative 6 on the left, equals 6x minus 3. X needs to live alone. I need to get rid of the negative 3, and I need to get rid of that coefficient 6. Start from the outside. Add 3 to both sides. I get negative 3 equals 6x. X needs to be isolated. Divide both sides, which all terms, by 6. And I get negative 1/2 equals x, or negative 0.5. Here are a whole bunch that you could practice with. So I would recommend that you pause the video at this time. If this wasn't review, we would of course be doing each of these together, but this is review for my class. I need you to go ahead and try some. So pause your video, try a couple. All right, welcome back. Here are our answers. Don't worry about this homework and stuff on the side. This was all for my class during the school year. I'm just going to leave it there for now. Here are your solutions to your variables. When I give you a quiz and I ask you to state the solution, this is what I'm looking for. X equals 7, n equals 4. You are solving for the variable. Examples. Here I have 7x minus 4 equals negative 2x plus 1 plus 9x minus 5. Okay, I have to clean this up. This is a mess. I have a negative 2x and a positive 9x, positive 7x. A positive 1 and a negative 5 makes a negative 4. You can see immediately that these two sides equal each other. But that's all right. Keep going. I subtract 4 from both sides. I get 7x equals 7x. Divide by 7. X equals x. Well, what if I had subtracted the 7x first and I had eliminated the x's and there were none? I would be left with negative 4 equals negative 4. Now what? I'm supposed to solve for a value for x and I don't have one. This is called an identity. This is when all real numbers can be the solution. No matter what value you substitute in for the variable, the equation will be true. No matter what value x is. If x is 3, then this x is 3. 3 equals 3. Negative 4 equals negative 4. It doesn't matter what the x value is. This is called an identity equation, and the solution is all real numbers. These are the tricky ones. These are the ones when you're taking those standardized tests and you can't figure it out. It's because it's one of these exceptions. All real numbers. Please take your time with it. What about here? Let's clean it up. 8x plus 6 minus 9x. I have two like terms. An 8x and negative 9 makes a negative 1x plus 6. Over here I have a negative 1x. There's an invisible 1 in front of it. A 2 and a negative 15 makes negative 13. I choose to add 13 to both sides. I get negative 1x plus 19 equals negative 1x. Okay, move the x's to the other side. I add 1x to both sides. I get 19 equals 0. Well, that doesn't make sense. 19 does not equal 0. 19 will never equal 0. Okay, I don't know what I'm doing then. So let's try something else. Okay, I cleaned it up, and this time I get rid of the x's first. So I add 1x to both sides, and I get 6 equals negative 13. Okay, 6 does not equal negative 13, and it never will equal negative 13. 6 will never equal negative 13. Something's wrong. I can't solve it. I don't know what to do. I can't solve it because there is no solution to this equation. When you eliminate the variables and the constants do not equal each other, there is no solution. So we went from all real numbers as the solution because they do equal each other to they don't equal each other, so there is no solution. Some examples for you. I'd like you to try all three of these. So let's pause the video again while you try these three examples. Welcome back. Let's take a look at the answers. My first one, 33 equals 33. Or you would have had 6x equals 6x, divide by 6, and x equals x, means my solution is all real numbers. My next one, I get two constants that do not equal each other, no solution. And my last one was a basic equation, and I was able to solve for x equals 4. Just because this says 4 equals 4x, that's not the same. There's a variable on one side, okay? So be careful. An equation with variables on both sides can have one solution, which is the most common. So x equals 4, y equals 2, one solution. You can have infinite solutions, which means all real numbers, and this is when both sides are identical, they equal each other. Or you can have no solution, when the two sides cannot be true. Clearly, this is very important to remember. So often you're trying to solve and you're going, I don't get it, I can't do it, because maybe you can't, because there's no solution. Please take your time. Now, usually I like to make fractions a separate slide, but I'm going to go ahead and add it on and go through it as a reminder. Remember that when you have a denominator with a fraction, all you do is multiply every term by the common denominator. In this case, it's 5. You multiply every term times 5, and this will eliminate your denominators, and you will have an equation. And now you can take that equation, move your m's to one side, and solve for m. Very complicated. I'm not going back into it because we've already done this, and this is just me showing you another review. Of course, you can stop the video and look at it, but I just want to give you a chance to review this entire section. In this case, I had a 2 and a 3. Not very many variables. Their common denominator would be a 6, which is also their common multiple. Multiply every term, not just the fractions. Every term by 6. I eliminate all the denominators. They're all gone using cross-canceling. Now I can just take my equation and solve for t. I have a common denominator. It's 8. Okay, I can't just get rid of it. I still have to multiply every term by 8. I do that, cross-cancel, and I have an equation. 3y minus 72 equals 104 plus y. Once you understand this multiplying by the common multiple, also the common denominator, you eliminate fractions. And that's our goal, eliminate fractions. Your big mistake, I already know what's going to be. You're going to forget to multiply the whole numbers. You're going to multiply just the fractions, and you can't. You have to multiply every term. I have a 3. I have one fraction. That's all I have is one fraction. Doesn't matter. I have to multiply every term by 3. The 2x minus 9, but you never actually multiply because you cross-cancel and eliminate the 3. 3 times 8, 3 times 3x. Now I have my equation. Be careful. Just for fun. What if, they love this question on a standardized test. Here are my perimeters. I tell you that these two perimeters equal each other. Solve for x. That's okay. I can add up these 4 sides. X plus 2 plus x plus 2 plus x. That gives me 4 x's. And a 2 and a 2 is 4. So this side equals 4x. Let me just type it in for the heck of it right at the moment. That gives me 4x plus 4 on this side. What do I have over here? I have x plus 6 plus x plus 4. Over here, I have 3x plus 6 plus 4, 10. Guess what? I told you that these equal each other. So if these equal each other, I have an equation. I take my 2 sides, I have an equation, and I solve for x. Once I solve for x, I substitute it back into the problem, and I solve for what is the perimeter. So with knowing the only information I knew is that they equaled each other. Made an equation for both sides, and now I need to solve for x. I did 4x plus 4 equals 3x plus 10. Subtracted 3x from both sides. Now I had 1x plus 4. Subtract 4 from both sides. X equals 6. I replaced every x with the value 6. And I was able to realize that the perimeter is 28. They love this question, and you really should go back and look at this one more time and try to do it on your own. Even though I've given you the answer now, try to do it on your own. I hope you enjoyed integers. We are done with integers, at least until next year, and thanks for watching.